Test review sheet number 2, question number 6. Find the areas of the triangles below using this formula. This is the way in your flip book we learned to use sine or use trigonometry to find the area of a triangle. So you can find an area of any triangle without knowing the height of the triangle, as long as you know two sides and the included angle. Now, as you recall from this class, when you see this formula, typically what we do is we look for the angle C, and then A and B are the side lengths of the two sides that surround that particular angle. So it's actually pretty easy to do, just plug in some information. So let's do this. The area of this first triangle is equal to 1/2 times the length of AB here, which is 12, times the length of BC, which is 9, and then you multiply it times sine of the included angle, which is sine of 57. We can put that in our calculator all in one shot. Let's see if we can show me doing this. So I'm going to go ahead and put in my first fraction, 1/2, 1 divided by 2. I'm going to put that in parentheses, and then we'll go ahead and put in 12, and then we'll put in parentheses 9, and then I'm going to multiply. Even though it's going to assume multiplication, let's just put the multiplication sign times sine of 57. So take a look at how I put that. Oops, sine already had a parentheses. Okay, 1/2 times 12 times 9 times sine of 57, press equal. We've got 45.28, so we can round that to 45.3. So area is equal to, oops, let's make that approximately 45.3. And our unit of measure is, remember with area, it is squared, millimeters squared. So that's all there is to it. Let's do the next one. How do we find the area of this triangle? If you want to, class, just on this one, we could have labeled this as A, small a. We could have labeled this as small b, and this as small c, but I want you to see that might confuse you here because it doesn't match up with the formula. So don't worry about labeling on this. Just see that we're just looking for two sides and the included angle. So in this case, you've got the area of this triangle is equal to 1/2 times 12 times 16, and then times sine of the included angle, which is 52. Put that in your calculator and you will get approximately 75.6, and our unit of measure is inches, so area is going to be inches squared. That's all there is to it. Alright, let's take a look at number 7. Here's a triangle ABC. If sine of angle A equals 36 over 85, what is cosine of angle B? If you go back and look on question number 4 and number 2, you will see that we learned this important property. When you know the sine of one angle, then you know that's going to be equal to the cosine of the other acute angle. So that means these two ratios are the same. And so cosine of angle B is just 36 over 85. Now you can change it to a decimal if you want to, but I can just leave it as a fraction to show that I understand they are the same. For tangent, if tangent of angle A is 36 over 77, what is tangent of angle B? Well, we learned from number 2 and number 4 and from our unit, we're learning that in our flip book and in our homework, that tangent of these two angles, A and B, are just reciprocals. So if tangent of angle A is 36 over 77, tangent of angle B is 77 over 36. And let's write a word here. These are reciprocals. Remember, they are not opposite reciprocal. Opposite reciprocal would say this must be negative 77 over 36. They're just reciprocals. All right, question number 9. For the diagram below, the angle of elevation is 63 degrees and the distance from you to the tree is 52 feet. What is the estimated height of the tree? Now, of course, we're assuming this tree is growing straight up and down, which is creating a right triangle in our diagram. So let's go through our process. Always, we are going to write SOHCAHTOA. Our reference angle, we don't have a letter for it, and that's okay. I'll just put our reference angle as 63. This is the hypotenuse. That makes the height of the tree the opposite side, and the distance from me to the tree the adjacent side. So we know adjacent, we want opposite. Oops, I put OO. We want opposite, so what angle are we going to use? We know adjacent, we want opposite, that means it's going to be tangent. So our trig function is tangent. Let's write tangent of our reference angle, which is 63 degrees. Tangent is equal to opposite over adjacent. Opposite is h. Adjacent is 52. Now we got to get h by itself. And on this one, because the variable is on top in the numerator, we multiply it by the denominator to get 52 to go away. That puts 52 on the other side of our equation. So 52 times tangent of, let's get that right, I almost wrote 52 again, times tangent of 63 equals h. And now we can plug this in our calculator. H is approximately, let's see, 52 times tangent of 63. Let's press equal. We've got 102.05. Well, that 5 rounds the 0 up to 1. So 102.1 is approximately 102.1. And that's going to be in feet. Let's go ahead and write our answer as a sentence. The height of the tree I'll try to write a little neater, is 102.1 feet. So basic trigonometry for question number 9. Let's see if we can fit in question number 10 if possible. Let's take a look. I think so. A student wants to measure the height of a flagpole using a clinometer, which we've done already in class. Using a clinometer, he determines that while standing 1,284 inches from the pole, the angle made from his eyes to the top of the pole is 39 degrees. The distance from the ground to his eyes is 56 inches. What is the height of the flagpole? Well, everything is already labeled here on this diagram. All we have to do is start working our trig. So we know this is hypotenuse. If we're going to use 39 as our reference angle, in fact, I should have circled the reference angle on question number 9. Let's do that. Okay, there's our reference angle. That would make this length AB opposite. And that would make 1284 adjacent. And let's go through SOHCAHTOA. You've got SOHCAHTOA. Our reference angle is 39. I'm not even going to write that. We know adjacent. We want opposite, adjacent, and opposite. And that ends up being tangent. So we're going to use tangent. Alright, so our formula is going to be tangent of angle 39, our reference angle, is equal to opposite over adjacent. Well, opposite is our unknown. Let's put an X there. Opposites are unknown. Adjacent is 1284. You can see this works out very much like the tree problem in question number 9. Okay, I got to get x by itself. I'm going to multiply both sides by 1289, and that ends up, 1284. So 1284 times tangent of 39 is equal to x. Let's go ahead and put that in our calculator. X is approximately 1284 times tangent of 39 degrees equals 1039.76. That's 1039.8 if we round to 1. 1039.8. 1039.8. Okay, so our final answer is, we just found what AB is. So this value right here, AB, so I'm going to put this in the answer. AB is approximately 1039.8, and we know that our height is 56 inches, and that means the height of the flagpole is going to be AB plus CD, and that's going to be 1039.8 plus 56. Let's do that now. 1039.8, whoops, 1039.8 plus 56 equals, and our answer is 1095.8 equals 1095.8. So our final answer should be written as a sentence. The flagpole height is 1095.8, and that is, I think I said feet before. That's actually in inches, class. You look at the measurements here, everything is in inches. 1095.8 inches. Let me check my answer there real quick. 1095.8. Yep, got it. And that's end of question number 10.